Okay, very good day to everyone. So today our team is going to present on our product, which is residential fuel cell. And we have three members in our team, which is me, Shu Wen, Divagar, and also Nurain Zuhairah. So firstly, we're going to identify that the following chemical reactions that involved in our residential fuel cell. Firstly will be the hydrogen oxidations and also the oxygen reduction reactions that going to synthesize the byproduct of water. And there's an operating temperature for this fuel cell which is around 60 degrees Celsius because there's a heat will be released during the reactions process. And for the operating pressure will be 1.2 atm. So following for that, this residential fuel cell is having the special attributes, which is the environmental friendly because it is using the low carbon footprint. Second will be there's a reductions in the electricity cost because this is a self-supply electricity in the household that we're going to supply on our own instead of relying on the electricity that's supplied by the authority. And the third one will be the simple appearance. So this can ensure that for the consumer is going to use our product, they don't need to do any renovations to their house. They can straight away just install to their residence. And the fourth will be the weather resistance, as this fuel cell is going to locate at outdoor. So a weather resistant, which is to prevent the rainwater and also any those the rusty in order to protect the device inside from the damage. Lastly will be the low-cost catalyst, which is some modifications on our product. We're using the nitrogen doped graphite instead of the platinum as the common one. So this one, and also because the platinum is having a high costs and also depleting. This is a reason that we're choosing nitrogen doped graphite as our catalyst in this product.
Okay, next I'm going to tell on the dominant key rate where our process or project, the dominant key rate is based on the lifetime of the products as well as the power generated by the products to measure the effectiveness of our project. The possible chemical triggers is the doping level of the catalyst as different doping level can affect the efficiency of our fuel cell. Next is the configuration of the nitrogen in the catalyst and the type of reducing agent in the production of the catalyst, the nitrogen doped graphene, because there are several types of reducing agents such as hydrazine hydrate and urea. Next is the scale up approach and scale down approach. To scale up our production, we need to increase the hydrogen supply to increase the production of fuel cell. Next, we can attract more investor to invest in our project by changing the design to be more creative so that we can get higher capital to increase our production and also to increase the amount of catalyst and its facilities so that we can produce a large capacity or we can produce it in batch production. To scale down our project, we can try to minimize the size of the fuel cell and reduce the facilities needed. For the design function, our products were designed to produce electricity in the residential area by using hydrogen fuel cell to replace the fossil fuels that are depleting. The design will require hydrogen supply as the fuel to generate electricity and use nitrogen catalyst to lower the activation energy.
For the product specification, the fuel, first is the fuel used is the hydrogen gas. Next, power generation is about 700 watts. Efficiency of the fuel cell is 40 to 50%. The weight of the fuel cell is 70 kilograms. Body size is silver. The size is 500, width 300, distance and 900 height in millimeters. And next is the water can be taken off for domestic usage. So this is the pattern table. for our product. The first criteria is high electrical conductivity. So the product description is nitrogen lubrication used thinner and catered for high conductivity and less power loss and speed. There were similar patterns from US, which are graphene coated as bipolar plates, and European pattern, which is graphene oxide polymer aerogels and electrodes. And there were also similar journals, which is recent advances in fuel cell technology and its applications. The next is criteria is compact size. For compact size, the product description is space saving, and one similar US pattern was found, which is hydrogen fuel system for a vehicle. And the third criteria is fireproof material. For fireproof material, the product description is to reduce the risk of fire and explosion. And the similar journal that was found is the performance of calcium silicate board partition, fireproof drywall assembly with junction box under fire. So this has a potential to be patented. Next is criteria is highly efficient. So product description is calcined fuel cell using hydrogen and oxygen. Similar US pattern was found and European pattern was also found. The final criteria is safe byproduct. The product description is byproduct of water is safe for the is safe, and there was similar US pattern found. Next slide. So this is the house of quality diagram. So to explain the house of quality diagram, first we have to see the custom requirements and the installation cost, safety, maintenance, cost savings, lifetime, space, and hydrogen as fuel source. And each of them are ranked between the 1 to 5, and the design requirement from our future is high electrical conductivity, complex high material, and see what the highest importance is given to the installation cost and the maintenance of the hydrogen fuel cell, and the lowest was given to uh, space for space. So the percent importance based on the house of quality diagram is E. Yeah. I cannot see the down there. Is for the first part is 20%, the second part is 11%, the third is also 11%, the highly efficient one is 34%, and the safe byproduct is 22%. Then the strong correlation is between high electrical conductivity and highly efficient. Another strong correlation was also between fireproof material and byproducts. As you can see, our competitors are also evaluated in this point. They are here, the Hyundai fuel cell and Dosan fuel cell. So next. So this is the life cycle analysis for the hydro fuel cell. So first is the graphite and platinum, the raw material for the cathode and anode of the fuel cell. So first, they enter the manufacturing stage. For manufacturing stage, polishing and combining chemicals like acetic acid will be used, and some of the chemicals effluents will be released to the factory. And after the manufacturing, membrane electrodes are produced. After the membrane electrodes are produced, we need raw raw fuel, which is hydrogen gas, which is produced from the power plant by using fuel cell to produce electricity. From the electricity is used for the electrolysis of water to produce hydrogen gas and oxygen. AH hydrogen will be used as fuel for the hydrogen fuel cell. Then the hydrogen fuel cells, the remaining the byproduct of hydrogen fuel cells will be used for watering plants. And after a while, the less efficient fuel cell will be recycled. The recycled product will be entered to the manufacturing, which is to recycle the graphite and platinum. And finally, the remaining of the recycle will be sent to the disposal, which is the landfill. Okay. Thank you, everyone.